Right, morning once again. We're gonna continue with parallel resistors. All right. Parallel resistors is when you connect your resistors um, in different channels. Like for example here, like this. So the first one, obviously with the battery, it's in series. Was this one wire that is connecting it to the resistor. So this is a series with the battery. But when it comes here, now they're in parallel because the wire comes, all right, then it splits here. When it splits, you've got one channel there, you have another channel there. So these two resistors are in parallel, all right, connected in parallel because the wire splits there. All right, then if you look at the third diagram, all right, three resistors in parallel. So the wire here splits three ways. One way to this resistor, the other way to this other resistor, then the other way to that other resistor. Then after that, they meet again, then they continue here, all right? And please note the conventional direction in which current flows. It flows from positive to negative. So it flows from here positive, right? When it gets here, it's gonna split. Some will flow that way, some will flow that way, some will flow that way. Then here they combine again, then they move, right? So that is a connection in parallel, right? So let's look at some of the points here. When we add resistors in parallel to a circuit, there are more paths for the current to flow, which ensures that the current splits across the different paths. All right. So current is gonna split in many parts. So that's what how you know whether the resistors are in series or parallel. Right. Then the next one, the voltage is the same across the resistors. Right. So what does that mean? It means when you've got resistors in parallel, all of them are gonna get the same voltage. The voltage is the same across the resistors. The voltage across the battery um, the voltage across the battery in the circuit is equal to the voltage across each of the parallel connection, right? Okay, Stembiso says you can't hear me. You guys, can you hear me? Hello? Can you hear me?
Yes, sir.
Okay, Stembiso is saying he can't hear me. I'm not sure whether, I think maybe it could be his app or something. Just check your settings there, Stembiso. I'm not sure. Okay, right. The voltage is the same across the resistors. The voltage across the battery in the circuit is equal to the voltage across each of the parallel resistors. So voltage of the battery will be the same as V1, V2, V3. So basically what I'm saying is this: the voltage across the battery here for circuit 1, it will be the same. So if this one reads 5 volts, this one is also going to be 5 volts. So if this one is 5 volts here, the first resistor here will have 5 volts. The second one will also have 5 volts. Same applies here. If the battery is 5 volts, this will get 5 volts, 5 volts, 5 volts. So voltage across parallel connection here is going to be the same for all the resistors. Right, that's what the point is saying here. Then the next one, the resistance to the flow of current decreases. The resistance to the flow of current decreases. The total resistance is given by, so the calculation for when you're doing resistors in parallel, what are you gonna say? You're gonna say 1 over R parallel is equal to 1 over R1 plus 1 over R2 and so on and so on. So for you to get total resistance for resistors that are in parallel, right? You have to use this particular formula here. I will elaborate it. Let me just try and open my way I normally write. Just a second. Okay. Right. While I'm opening the other one, we can just look at this simulator here. On this simulator here, I hope you can see it. Can you see it? Can you see the screen that I've opened now?
Yes, sir.
Okay. So basically, this is a battery here. All right. That's a switch. That's a bulb that's connected in parallel. So if I close the switch here, all right, your current is going to flow. All right, so when it gets here, there's a splitting that takes place here. So your current splits. All right, some of the current will flow this way, some of the current will flow this way. When you get here, then your current here, it combines, then it continues. All right. So basically, if you want to measure, let's say you want to measure your current, your voltmeter. If you want to measure the voltage across here, right, you're going to check there. The voltage here, it's saying 12 volts. So the voltage across the battery is saying 12 volts, right? If you move to the first bulb here, what are we going to see? We're going to see, let's check the voltage here on the bulb. All right, on the bulb says 11,911. But if you round off, it's also 12 volts. So what does that mean? It means the voltage across the battery is almost the same as the one in the first bulb here. If I move again to the other bulb and check the voltage, it's also 11,99 volts, right? Which is, when you round off, it's still 12. So what does that mean? It means the voltage across the battery is the same as the voltage across the all the connectivities or all the bulbs that are in parallel. They get the same voltage here, right? Then we move on to current. I don't know what happened here. Okay. Okay. Then we move on to current. I just put the, let me just put this one aside here. Okay. There's another program that is trying to open here. Okay. Right. So if I bring an ammeter, where's my ammeter now? Okay. If I bring an ammeter here, and measure the current here, all right, let me just split this junction here for now. Right, if I put an ammeter here to measure the total current here, all right, the value that we get, it's 4,80 amperes. That's the current that we are getting, total current. All right, if I put an ammeter in this other branch here, let me see if I can put another ammeter here. I hope you can see what I'm doing here. Okay. Let's split here. Right. Right. Now check here. When I hope you can see this particular value, this reading here. I'm not sure if you can see it. Okay. Right. So your current here is 4,80. But when you get here, your current here in this first channel here, it's 240. It's 240. If I put another ammeter here, you see what I'm trying to illustrate here. Right, if I put an ammeter here, okay, I connect an ammeter here. Right, so the value that you have here, when current gets here by this junction here, it splits into two, right, and it splits equally, right? So what do you see? It means the total current here was 4,80 amperes. When it gets here, it splits into two. So it splits proportionally depending on the resistance of these two bulbs here. So this one is going to get 2,4 amperes, and this one here is going to get 2,4 amperes. When we get at this junction here, right? They're going to change here, right? They're going to add. Now the current that was flowing here and here, they sum up here. And the current that is going to flow in this outer channel here is now 480, right? Let me just add the, maybe change the voltage, increase the voltage here, right? If I can just increase the voltage, let's say to 14, right? 14 here, all right? You see that the speed at which electrons are flowing in this channel is faster because here they sum up here. But when it gets here, it splits, right? Halfway. So it gets, like I've changed the voltage here. The current here also increases, now 560, right? Then the current here is going to be 280, 280, right? So current is split proportionally or equally here because the two bulbs have got the same resistance. Let's say I change the resistance of this bulb here. Maybe make it 10. If I make it 10, all right. If I make it 10, then what do you see here? I hope you can see this, right? So the current in this channel where there's more resistance, the current decreases here because there's more resistance. So the higher the resistance, the lesser current it gets. But still, when I add 2,80 plus 1,40, it's going to give me the total of 420. So when the current gets, the two are going to add 1,4 plus 2,8, which gives me 4,2. So in the outer year, you're going to have 4,2 of current flowing, which is your total current. When it gets here, it splits. So what does that tell us? It tells us that resistors, a bulb is a resistor because it has got a resistance, right? Resistors that are in parallel, they are current dividers. So the current, when it gets here, it splits proportionally. The one with the higher resistance gets smaller current. The one with the lower resistance gets more current. So this is what happens here when we get here. When they come here again at this junction here, we sum up the current in this channel, the current in the other channel, they add up, then we've got a total current flowing here, right? When it comes here, splits again. Higher resistance, lesser current. Lower resistance, more current. Do you understand that?
Yes, sir.
Right. Okay, so that's what we have here. Right, let's move on to the next one. Okay. Let me just open again here. Okay. Right, so this is what we're talking about here. The voltage is the same. So you're gonna get the same voltage right here. You get the same voltage for all the resistors that are in parallel. They get the same voltage. How do you calculate the resistance? For you to calculate the total resistance, you're gonna do this. Let me just open again another one. Um, right. Just change here. Right. So the formula that I'm talking about is this one here. When you're looking at resistors in parallel, you're going to have 1 over R parallel, right, is equal to 1 over R1. 1 over R1 plus 1 over R2. Right? So if you like, in my case, I've got two bulbs that are in parallel. So for me to get the answer, what am I gonna say? If I want the total resistance, I'm gonna say, let's say the other one is 5. I'm gonna say 1 over 5 plus, let's say the other one is 10. I'm gonna say 1 over 10. Right, which is equal to, I look for my LCD. You can use your calculator here. My LCD here is 10. Then I'm going to say 5 into 10 goes how many times? 2 times. Times 1, I get a 2. Plus 10 into 10 goes once. Multiply by 1, I get a 1. All right? Then my final answer here is going to be 3 out of 10. So I'm going to get 3 over 10. But don't forget, here I had 1 over R parallel. I had 1 over R parallel. I can use 2 lines or can I use P for parallel. But this is not my final answer. I need to flip this because I need R parallel. So I'm going to flip this. So I invert this. 1 over R parallel becomes R parallel over 1. What I do on the left-hand side, I also do it on the right-hand side. So I'm going to have 10 over 3. 10 divided by 3. Right? That becomes my my total there. Then I can simplify this. 3 into 10, you're going to get a 3. Remainder 1. Then into 10 again, I get a 3. So I'm going to get 3, 3, 3, 3. Right? So the total resistance for this circuit here is going to be 3,33 ohms. That's how I get the total resistance. Clear? Right, so I repeat again, for you to get the total resistance for resistors in parallel, you use the formula 1 over Rp, where P is parallel, is equal to 1 divided by R1, where R1 is the resistance of the first resistor, plus 1 over R2, where R2 is the resistance of the second resistor. If I had a third resistor, then I'm going to add it and do the calculation. All right, so if the first resistor was 5, the resistance was 5 ohms, and the other one was 10 ohms, then I'm going to say 1 over 5 plus 1 over 10. All right, you can use a calculator here, it's allowed. You don't have to know the addition of fractions in detail. Then, like here, I don't have a calculator, so I do it mentally. So I'm going to look for a LCD, lowest common denominator of 5 and 10, which is 10. 5 into 10 goes 2 times. 2 times 1, I get a 2. Plus 10 into 10 goes once. 1 times 1, I get a 1. Then I add 3 plus 1 gives me a 3 over 10. Right. This is not my final answer because my R parallel is a denominator. I have to invert this. So I'm going to invert this so it becomes R parallel over 1. Then what you do on the left-hand side, you do it on the right-hand side. So then I'm going to have 10 over 3. So I flip this. I'm going to flip this. Right? I flip these two. The top one goes down, the bottom one goes up. Right? Then I'm going to have 10 over 3. Then I divide. 10 divided by 3 gives me 3,33 ohms. This number recurs, so I round it off to 2 decimal places. That's how I get that. Right. Then, if you don't like this formula here, we can also derive a formula for this. Right. The formula that we can derive here is this. If I've got 1 over R parallel is equal to 1 over R1 plus 1 over R2. I've got 1 over R2. Right? We can have a general formula for this. So what am I going to say? I'm going to say LCD. I've got R1 and R2. So for me to find the lowest common denominator, I multiply the 2. So I'm going to have R1 multiplied by R2. That's my LCD there. Right? Then I say R1 into R1 times R2. I'm going to get R2. So I get R2 plus, I say R2 into R1 times R2. I'm going to get R1. Right? Then I flip, because I've got here, this answer that I have is for 1 over R parallel. When I flip it, what am I going to get? I'm going to get R parallel is equal to, I'm going to flip these two. So my R1, my product is there for R1 and R2 goes on top. I get my R2 Excuse my writing here, I'm using a mouse. My screen here is not touch. So my handwriting is going to be otherwise. So I've got my R2 plus R1. So this becomes the general formula for two resistors that are in parallel. So every time you're given this, you're going to be using this, right? Where you're going to say, for me to get the resistors, two resistors that are in parallel, what am I going to say? I'm going to say R1 times R2 divided by the sum, R2 plus R1. Like in our case, we had the 5 ohm and 10 ohm that were in parallel. So for me to get the answer, what am I going to say? I'm going to just going to say 5 multiplied by 10, 5 multiplied by 10 divide by 5 plus 10. So at the top, I multiply. At the bottom, I add. So my answer here is going to be equal to 5 times 10 is going to give me 50. It gives me 50. Divide by 15. All right? And 15 into 50 goes 3 times. Remainder 5. Then you've got a 5. All right? You add a 0. 15 into 50 gives a 3. Remainder 5. It recurs. So your answer is 3, 3 ohms. So this is basically what you do if you are using this formula here. So you don't have to every time flip. So it's easier to work with this one because people forget to do the flipping in the previous one, right? But for this one here, you are able just to multiply your at the numerator and add on the denominator, you get your answer. No flipping. So that you don't lose marks if you forget to flip, right? So this is how you calculate R parallel, right? For resistors, this is R total for parallel, right? So this is your R total resistance for resistors that are in parallel. You have to use this formula, or you can use the original formula, which is 1 over R1 plus 1 over R2, where you have to flip. Is that clear? Is it clear? Guys, are you there? Right. Anyway, I hope you are with me. Right. We move on to the next one. So basically, to summarize here, voltage for resistors that are in parallel. Right. Voltage for resistors that are in parallel. They all have the same voltage. So the 5 and the 10 will get the same voltage. How do you get the total resistance? You're going to have to use the formula 1 over R1 plus 1 over R2. Or you can use the one that you've derived now, which is R1 times R2 over R1 plus R2, right? That's a formula. But now if you've got more than 3 resistors, we need to derive another formula. That formula is not going to work because your sum is going to be different. I think I'll do that if we've got extra time there for the third one. Or maybe if I can just show you if there are 3 resistors quickly. If there are 3 resistors quickly, it's going to become a bit challenging there, all right? If there are 3, but I'll derive it for you, all right? So if there are 3, what are you going to say? You're going to say 1 over R parallel is equal to 1 over R1 plus 1 over R2 plus 1 over R3, right? Which is going to be equal to over your LCD. You're going to multiply everything here, R1 plus R1 multiplied by R2 multiplied by R3. So your LCD is going to be R1 multiplied by R2 multiplied by R3. So the formula gets a bit complicated there. So you're going to say R1 goes how many times into this denominator here? So your R1 cancels with R1, so it goes R2, R3 times. So it goes R2, R3 times. So this is a product of R1 and R3. Plus, you do the next one, R2 into this, your R2 is going to cancel there. So you remain with R1 and R3. So you're going to have R1 and R3. Right? Plus, you do the same here. R3 goes how many times into this? Your R3 cancels with your R3. Then you're remaining with R1, R2. So you're going to have your R1 multiplied by R2. Right? Then you flip your formula. So for me to get R parallel, here, I'm going to flip this. I'm going to take this up, right? And what is up must come down here, must be my denominator. So I'm going to have my R1 multiplied by R2 multiplied by R3. Then my denominator now becomes the one that was on top, which is R2, R3, plus my R1, R2, plus I've got my R1, R3, sorry, R2. Sorry, this is 2, and this is your 3. But it doesn't matter because you're still adding, so it doesn't matter whether you swap. So you must just know here I've got a 2 and a 3, here I've got a 1 and a 3, and here I've got a 1 and 2, as long as you're combining all of them. So this becomes the formula for 3 resistors that are in parallel, right? If you want their total resistance. But as you, if you memorize this, then it's easy. But now if you get confused here, it's rather you use your formula 1 over R1 plus 1 over R3, you get your answer, then you flip. The only problem with this one, people forget to flip. That's the challenge. If you forget to flip, you leave your answer like this, then it's going to be incorrect, right? So if you look at an example for 3 resistors that are in parallel, maybe you've got 3 resistors that are in parallel, you've got 1 resistor there. Let's say this is 1 ohm, or let's say 2 ohms, right? You've got 2 ohms. You've got the one that we had earlier on. It was a 5 ohm, right? You've got your 5 ohm. Then you've got another resistor again that is in parallel. Well, let's say it was a 10 ohm. So you're going to have your 10 ohm here, right? You have your 10 ohm. These ones are connected in parallel, right? So you join them to the battery up there. Maybe you've got your battery somewhere here, right? That's your battery, you join, right? If you want the total resistance, what are we gonna say? If you want R parallel, we're just gonna say R parallel using that formula there is equal to, right? We said at the top, you've got your R1, so I'll take my R1 to be 2, so I'm gonna have 2 plus the next, sorry, here I'm multiplying, I'm not adding. At the top, I multiply. So I'm going to multiply here. So it's going to be 2 times, I need a bracket here. Okay. So it's going to be 2 times 5 times 10 over, right? Then I'm going to have at the bottom, I'm going to have a 2 times 5. Can't write nicely here. Okay. So it's going to be 2 times 5. 2 times 5 plus I've got 2 times 10. 2 times 10 plus, right, I've multiplied 2 times 5, 2 times 10. What is left is 5 times 10. So I'm going to multiply 5 times 10. Right, that's what I have there. So at the top, I'm going to have 2 times 5, which is 10. 10 times 10 is 100. So I'm going to have 100 here at the top. Right at the bottom, I'm going to have 2 times 5, which is 10. 2 times 10, which is 20. That makes it 30. All right, 5 times 10, that's 50. 50 plus 30, that gives me 80. So my answer is 80. All right, then I'm going to cancel the zeros here. I cancel the zeros. I've got 10 over 8, which is going to simplify to 8 into 10 goes once. Remainder 2. 8 into 20 goes 2 times. Remainder 4. Then 8 into 40 goes 5 times. So my answer is going to be 1.25 ohms. That will be the total resistance for these 3 resistors here. What do you notice here? If you look at this answer that I got here, if you look at this particular answer that I have here, all right, it's 1.25. And if you check here, the smallest resistor here, it's a 2 ohms, all right? So when you add resistors in parallel, your total resistance decreases. So you get the answer that is smaller than the smallest resistor. My smallest resistor is 2. So my answer must be less than 2. So I get 1.25. So it means the more resistors you add in parallel, the lesser the resistance. It means the more the current that is going to flow. Clear? I repeat again. When you add resistors in parallel, all right, the total resistance is always smaller than the smallest resistor in that connection. What is my smallest resistor here? It's a 2. So when I add 2, 5, and 10 in parallel, my answer must be less than 2. So my answer here is 1.25 ohms. So the more resistors you add in parallel, the lesser the total resistance. Right. If you look at the plugs that we use, the multi plug that we have, all those connections there, they're all in parallel, right? So the more you add more of those particular components, you put your iron, you put your TV, you put your stove, then your resistance decreases. That's why on that multi plug, there's a small switch there that trips, because the more components that you're going to be adding to connect to that multi plug, the lesser the resistance. It means the more the current. If there's more current flowing, then it's likely to burn. It's like the cable is going to become hot. And when it becomes hot, what is going to happen? You're going to have now fire. The cable might burn. So it has to trip so to avoid fire. So that's what you have on that multi. They're all connected in parallel. The more components that you're going to connect, the lower the resistance. The lower the resistance, the more the current. Clear? Right. Then we look at the last one. The last part that you have is a combination. So you're going to have a combination of parallel and series. That's what we have at the end here. So for example, if I join here, my circuit here, right, what do you see? You see the ones that are in parallel. If you look at the resistance here, the resistance for these two, they are 5. This one is also 5. It's also 5. All right. Let's have a look at this one here. The resistance here is also 5. So all these bulbs, they've got the same resistance, right? But this one is brighter. Why is it brighter? Because the total current that is flowing in the outer one is it's higher. And remember, when current gets here, it splits, right? So you're going to get less current here, right? So these two are going to be dimmer and not as bright as this other one, because this bulb that is in series with the battery, it gets more current. So when it gets here, these two are now in parallel, right? So they get less current because the total current that was flowing in this bulb here splits to get half of that. So if maybe we can just measure the current there. Okay, it's going to take time. Only have about 3 minutes. Right. Okay. So here, this is what you have. The one that is in series will be brighter. Why? Because it gets more current. The one that is in parallel is less. It's dimmer. All right. Why? because it gets less current since current splits here by this junction here. When you get here again, the current is gonna combine, then the current flows into the outer circuit. Right, any questions? I don't know if you understand what I've been doing today here. Any questions? Hello? Ulufelo, any questions?
No, sir.
You understand what I've done?
Yes, sir.
Okay. Owen?
No, sir.
Okay. Jolisha, I think she's got a problem with the speaker there. Okay. And who else? Joshua, are you fine?
Yes, sir.
Okay. All right. So I will stop here. I will post the handout for you guys to do. I'll put some questions for you to just play around. I'll put some examples on resistors that are in parallel as well as a combination of this. But on Monday, maybe I'll look at an example where we do calculations for especially the combined one, because people need to understand if I've got a couple of resistors here, which one is in series, which one is in parallel, so that we're able to answer the questions. So I'm going to repeat the combined one, where there's series and parallel on Monday again, then we continue from there. So today, I will post a handout that has got only parallel so that I don't confuse the two. So I'll put only parallel where you're going to be doing some calculations and answering some questions. All right, please don't forget on Monday. On Monday, our times are going to change. All right. I'm going to post it on the WhatsApp group to confirm. I'm just waiting to see if there's a new timetable that we designed where you're going to have a slot for different subjects. So it will depend which subject. So the 11 o'clock slot, it has been taken by another subject. So we'll have hours at 2. So we'll have around in the afternoon. But I'll confirm it during the weekend so that you know what time are we going to have the lesson. But as for now, we keep it at 2. So if I don't communicate, please try to join at 2. Then we continue from there. Is that clear? Hello? Is it clear?
Yes, sir.
Okay. All right. So have a nice weekend. Let's meet on Monday. I'll post the work for you guys. Okay. Bye.